To solve this, the first thing I need to do is get the square root by itself. So I'm going to subtract 2 from both sides. So I end up with n plus 8. Now I need to get rid of the square root. In order to get rid of the square root, I have to square, because the square root and squares are opposite of each other. And what do I do to one side? I have to do to the other. Okay, so n plus 8 squared, remember it is not n squared plus 64. Be careful with that. You have to rewrite it as n plus 8 times n plus 8. So do not do the n squared plus 64. So if I distribute, I get n squared plus 8n plus 8n plus 64. I'm going to combine my like terms. Okay, so I noticed that my highest power is a square, so I'm going to have to factor. So what I'm going to do is I'm going to subtract 3n from both sides, and I'm also going to subtract 24 from both sides. Okay, so now I have a quadratic, and I'm going to factor. Need two numbers multiplied together that gives you n squared. Two numbers multiplied together that gives you 40. That when you add them, it's going to give you 13. So I'm going to try 8 and 5. So I'm going to check. Remember to do your happy face so you can check. So 8n plus 5n will give you your 13n. So that checks. And now I'm going to use the zero product property. So I'm going to break both of these factors up and set them equal to 0. So I end up with two answers, n equals to -5 and n equals to -8. But I'm not done, because now I have to check my work. Because there might be extraneous solution. So let me try the n equals -5. I'm going to substitute that back into my original equation. So everywhere I see an n, I'm going to substitute a -5. So 2 plus 3 equals 5. So that checks. So n equals -5 is an answer. So now I'm going to check n equals -8. So once again, everywhere you see a n, you're going to substitute a -8. Okay, so that one checks too. So I do have two answers. So my answer is going to be n equals to -5 and n equals to -8. Remember, for these type of problems, you always have to check for extraneous solutions.